Sam Ramadori of BrainBox AI. BrainBox AI uses deep learning, cloud-based computing algorithms, and a proprietary process to support a 24/7 self-operating building that requires no human intervention and enables maximum energy efficiency. Pre-commercialization tests have demonstrated that BrainBox AI enables a 25 to 35% reduction in total energy costs in less than 3 months, with low to no capex needed from property owners. It also improves occupant comfort by 60% and decreases the carbon footprint of a building by 20 to 40%. Sam, welcome to our digital stage. The stage is all yours.
Ashkan, can you hear me okay?
We hear you loud and clear. The stage is all yours, my friend.
Perfect, thank you. So thank you everyone for taking the time. We recognize it's turbulent times right now, so I'm sure people are dealing with a lot of short-term issues, but appreciate everyone's time here today. So here to introduce BrainBox AI. As Ashkan mentioned, we are a company that started developing a little over 3 years ago. For most of that, it was a development in stealth mode where we had several pilot buildings that we installed, and that is pre-launch that we were developing on and then proving out the technology. And we launched in May 2019. Those pilot buildings were relatively modest in size, a total of 500,000 square feet. And we've since then, since our launch in May of last year, quickly gone and installed in over 15 million square feet in various building types, and we'll walk through that. The base technology that BrainBox has developed has sought to address the energy consumption of HVAC systems. Everyone on this phone, I think, would recognize that the energy consumed by HVAC systems, both in commercial buildings and in the home, account for the largest majority of energy consumption. And though we're seeing pretty game-changing technologies in other major energy-consuming areas, HVAC systems in the commercial side has been somewhat slow to innovate. And what our inventor thought was a viable opportunity. He saw what artificial intelligence was doing in self-driving cars. This was 4 or 5 years ago. When he saw what it was able to do in terms of autonomously identifying self-learning opportunities or objects in the case of a self-driving car, and then autonomously reacting to situations, and all of that in the case of a self-driving car being done on second or millisecond basis. His big idea was, why can't we bring that same capability to commercial HVAC systems, where frankly we have the luxury of time. Decision making can be done in 5, 10, 15, even 1 hour blocks, and certainly less risk than a personal risk than a self-driving car. And so what BrainBox has developed is autonomous artificial intelligence that layers on top of existing HVAC systems. So as opposed to having today's HVAC system being purely reactive, so reacting to an event when it has already happened, what we seek to do using autonomous AI is to give the artificial intelligence the capability to predict what's going to happen in buildings, and specifically within each zone of the building, over a period of 1, 2, 3, 4, 5 hours out, with a very high degree of accuracy. And then using that, being able to make decisions autonomously that would optimize the energy consumption as well as the comfort of the building, or use occupants of the building. And so that has been the big step change that BrainBox AI has made, which is to take that autonomous capability and bring today's HVAC system from being purely reactive to being preemptive, and to make decisions based on what is going to be hitting the building in the next few hours, as opposed to what has already hit the building. The approach here involves a few steps. So using the artificial intelligence to learn, again, the behavior of each of the zones of the building. And if you take the example of a 30-story building, office tower that might have 10 or 15 zones per floor, where basically the AI is self-learning how each of those 3 or 4 or 500 zones behaves, and that relative to external factors, mainly the weather. And in the case of buildings where we have occupancy data, we would also include the occupancy data in terms of being an external factor to how the zones behave. At that point, it is learning over a number. We have about a 6 to 8 week learning period. Over that period, it is learning how each of the zones behave relative to the weather it is facing outside. And there is that loop of basically fighting to predict, being able to predict what's going to happen in a zone in the next few hours, and then ensuring that a very high level of accuracy. So going through that loop for a number of weeks of being able to get to what's going to happen 3 hours out in a zone with over 99.5% accuracy. With that capability in hand, we then convert the system to autonomous mode, where the AI is looking at each zone and then accumulated together the whole building, and having to decide or deciding what the optimal settings of the various equipment of the HVAC system should be in order to get to the comfort zone. So staying longer within the dead band and doing so in a way that uses less energy. So as an example, imagine a zone becoming very hot at noon when the sun is full out. Today's HVAC system engages at noon to fight that trend when that trend is already well on its way, in order to drag that temperature back down into the dead band. What our AI is seeking to do is to know that that event's going to happen, to know it at 9 a.m., that that noon event is going to happen, and to start optimizing the various settings right down to the individual VAV box, the fan, the air handling unit, and to decide what the optimal settings of each of those components are, in order to say, I am going to start fighting that trend before it happens, and in doing so ahead of time, using less energy. As well, the whole idea in fighting a future trend is that in many cases we're able to avoid it. So that noon event where the temperature goes above the cooling set point, rather than waiting for that to happen, our preemptive approach could make it such that that temperature never crosses the cooling set point. So in addition to energy savings, you're reducing the temperature swings in the zones and keeping it for a longer percentage of time within the dead band, and therefore improving tenant comfort. We just show here a snapshot. This is a retail store we've been plugged into, just to show the dark green line is the actual temperature, and the lighter green line is the prediction made by BrainBox AI, and this is over a period of 2 or 3 hours. So you can see that is quite very capable of predicting what the reaction is, or what the temperature is going to be in an individual zone, with a very high level of accuracy. As Ashkan mentioned, in many of the pilot buildings we're in, many in the pilot buildings we started off with, we saw energy savings of over 25 to 35%. These are a mixed set of buildings, so that would include retail stores, hotel, office, school setting. And with that, obviously, at that level of energy savings, you're having a meaningful impact on the carbon footprint of the building. As I mentioned before, the artificial intelligence has the dual goal of both improving the energy consumption, but also improving tenant comfort by keeping temperature for longer periods of time within the dead band. And in many cases, we're improving that materially, here indicating 60%. The technology, one of the strengths, and we think one of the reasons why we've been getting rapid installations, is the fact that to install requires one edge device, no other sensors, which connects directly into the current EMS or HVAC control system in the building. That one edge device, it's a box of about a foot wide by a foot tall, communicates to the cloud via a mobile connection, SIM card. That was purposefully done in order to mitigate some of the cybersecurity risk issues that are now more and more being raised in the market. That entire physical installation of that edge device is a 2 to 3 hour process. From that point starts that 6 to 8 week learning period. So low involvement in terms of time, resources, both from our side, but also from the building owner side for the physical installation. And for that 6 to 8 week learning period, we will have regular interactions with the building management team. But even within that 6 to 8 week period, it usually is well below 10 hours. So it's also a low time investment for the building staff. as well, so based on the fact that it is a recurring revenue model, it also has a very low upfront capex or a small modest installation fee that would have like a 2-3 month payback period. So as I've just described here, we basically have 4 steps to get to the autonomous running of the HVAC system. Starts with that 2 to 3 hour installation, then follows the 6 to 8 week learning period. And literally the AI is learning precisely how each individual building operates. As we all know, every building is different, even when you have 2 office buildings next to each other, let's say in a suburban setting where they look exactly the same. Just the internal layout and the rest start making it that they operate very differently. So the AI is going to self-learn how each individual building operates. Once that is done, we cannot transfer those set of algorithms to another building. They are molded around how that individual building operates. At that point, we shift into after the 6 to 8 week learning period, we shift into autonomous mode, and that's when the AI is making regular decisions. So we download data from the HVAC system every 5 minutes, and every 5 minutes we're providing a new set of instructions, optimal settings. So every 5 minutes, the AI is recalculating what each zone and what the building as a whole is going to face in the next 2, 3, 4, 5 hours, and deciding every 5 minutes whether certain modifications or changes need to be made to the settings of the individual components of the HVAC system. And that's what we call the autonomous mode. At that point, we like to highlight that the learning is continuous. So if, for instance, there's a change in the buildings, like a new layout of a certain floor for a new tenant, the AI will note that if the walls have changed, if you went to open concept from an office layout, traditional office layout, it will note different behavior in that specific zones of the building, and it will relearn the new layout of that office space, and then it basically stops predicting and stops autonomously deciding. It goes through a relearning period, and then overall advantages, as I mentioned, there's a low implementation cost, and it is a high ROI solution. The customer gets a net cash flow positive situation, typically within 3, 4, or 5 months of going into autonomous mode. The system, we've designed it to be control system agnostic, so we plug into the major HVAC control systems, either things like the brand names Honeywell, Johnson Control, Snyder, Siemens, and also to BACnet-based Modbus LawnWork-based systems, so that would cover the majority of the market. We continue to add to our library of HVAC control systems that we can communicate to. But at this point, we've covered the major ones and probably can accommodate something like 70 or 80% of the commercial real estate market. I should say that we plug into buildings. One of the requirements is that there be a centralized BMS system in place. That's one of our base requirements. As I mentioned before, it is the installation of one edge device, no additional sensors to be deployed. So the installation is rather quick and takes limited resources from the building's team. And that goes also for disengaging. If a customer is not satisfied with the service, it is a relatively simple process to disengage the AI and to disinstall the box. So in terms of a risk profile, especially relative to such a high ROI, it's a very attractive solution for most building owners or managers. Behind that is 24/7 monitoring. Again, it is an autonomous solution, so the monitoring is mostly verifying that nothing is going left or right or off course, and also picking up on whether there's any potential failures or degradation in the performance of equipment over time that we would then signal to the building owners. Lastly, in many cases, or most buildings out there today do not collect the data from their HVAC system unless you've implemented a specific solution. So in addition to providing the energy services, we are collecting all the data out of the HVAC system and storing it permanently, and that's data that belongs to the building owner. So At that point, they are accumulating a full set of data that they can keep forever to do future analysis. And we're also mapping that data to make the nomenclature consistent across the board. So if a building owner has multiple properties in a portfolio, they will be able to have multiple data sets that are all on the same consistent basis, which wish to do analysis if they wish in the future. In our case, we're using it to deliver the autonomous AI solution. As I mentioned, we've installed at this point, over 15 million square feet since we launched about 10 months ago. This is over 40 different property types. As I mentioned before, it goes from anything from office, retail to hotel. We're in institutional / school settings. We're multi-res. We're going to be installing soon into data centers. So it's a pretty broad mix of buildings we're able to plug into, and a lot of that has to do with the self-learning capabilities of artificial intelligence. If we had to dedicate a team every time we went into a new building to learn how that particular building type operates, we just would never be able to scale. And so the autonomous nature of the AI really supports the ability to have an easy install that can scale and that can apply to various building types. We have here these are four of our initial installations. So the first, an office building of about 140,000 square feet. The second, a hotel. In this hotel, we manage the common areas. And then in the third bucket there, 2 retail stores that are this is with a major retail chain that has stores of about 8,000 to 12,000 square foot in size. So even in the case of a relatively simple setup like that, where you have only air handling units, we're able to bring a material improvement in energy consumption. We have developed as well a dashboard that will allow the users to see how the performance of the building or the energy savings are progressing on a monthly basis. This dashboard also helps to visualize what algorithms are running at any particular time in terms of what optimization they are going after. And again, one of the strengths here when people talk about applying AI, I mean, one of the real benefits in terms of its scalability, the way it can operate autonomously, is that it really does go and pursue many hundreds of optimization opportunities that if you would try to do it on a human basis, you just would not be able to do. We typically do a Pareto analysis. We'll find that the 10 to 15 biggest opportunities and focus on those just because of the time required. In the case of artificial intelligence, it is really pursuing many more optimization opportunities, even down to the last 0.2% or 0.1%, because it can do so on a scalable basis. So just that summary of the company: we are a Montreal, Canada-based company founded in early 2017. We are now installed in 15 plus cities, over 30 clients, as we mentioned. And we have developed the technology in partnership with some very interesting groups, including the NREL in the US, McGill University, Concordia University, and in case people are not aware, Montreal's one of the major global hubs for artificial intelligence, so we were able to tap in to strong local talent. Today, we're a team of I think we're now at about 44 or 45 people. It is a very heavily engineering team. I think there's only about 7 or 8 of us that are not engineers within the company. So it is, we have built a team bringing together the disciplines that you would imagine are required to deliver on this solution. So AI specialists, HVAC control specialists, mechanical, electrical. So that's an overview of BrainBox. I want to leave some time for any questions that the group here might have. I might have kind of gone over certain concepts rather quickly. So certainly open to any questions.
Thank you, Sam. So for anyone that has any questions, please make sure you click on the Q&A chat feature, looking at the bottom of your screen. I see we have 4 questions. Some questions came through during your presentation, Sam. I'll start from the top, and I'll kind of go down that list. Have you guys applied this to garden style multifamily apartments?
So the application, as I mentioned before, the one thing we need is a centralized BMS. And in the world of multifamily, one of the challenges is that in a number of cases, you'll have a non-centralized system where in the individual units, there are thermostats that are and that control the local VAV box or even local air conditioner that are not connected to the central BMS. So in those cases there, we would only be able to manage the common areas, and in a lot of cases, that's just not a lot of space. So for multifamily, we would need a centralized system, including into each unit. There are solutions nowadays that are also being pushed independently of an AR solution like ours that people will consider installing wireless thermostats. And when you do that in each of the rooms, those wireless thermostats can be all connected to a gateway, and we can create basically a synthetic centralized BMS system. So in that way, we can get there, but clearly that the idea of installing wireless thermostats throughout the multifamily building. And again, wireless thermostats that would be able to manage either a valve in the unit that, in terms of when we're talking about a water loop, or manage the local cooling or heating unit in the room if there is one. We would require that kind of setup. So we like to say we can go into buildings low cost in the case like this, in a multifamily like this, that would need to be an investment up front to make it centralized.
So I see another question came in around at 2:40 again during your presentation. It said, the question asks, how did you measure occupant comfort increase by 60%?
So the being data driven, we like our data. Looking at occupant comfort, we have a couple of methods, but the main one is to measure the amount of time that your temperature is sitting within the dead band, the heating and cooling set points. And so as it is today, the temperature varies above and below those set points because the system only engages when the temperature goes above or below the set point. So you have that variability of the temperature swing going above those two set points. We seek to flatten that and have more time where the temperature is within that dead band. And that we would define as comfort, because the temperature's not going into zones that are too hot and too cold. So we say that in buildings we have seen that we're able to improve the amount of time that the temperature of a zone spends within the cooling and heating set point. And that improvement in many cases is, or on average, we're seeing a 60% improvement in the amount of time that the temperature is within that dead band. The other more anecdotal evidence, in many cases, buildings are tracking the number of hot and cold calls that they're getting, or that their building operator is getting. And in cases in buildings we've been installed, we've seen a pretty substantial decrease in those daily hot and cold calls. So I hope that that addresses that one.
Yeah, there's a few more, and a few more are actually coming through as we speak. What type of AI model does I'm sorry. What type of AI model does BrainBox use?
Yeah, so you've caught the weakest person on the team to answer that question, because I am not myself an engineer, but we do use models that are developed for other uses as well, long short-term memory type models. We have for mapping purposes used what is being used in genome sequencing, the artificial intelligence used in genome sequencing. So the team is constantly on top of new AI models being developed in the market and seeing whether they can apply or not. I'll be frank, there's someone on our team that could answer that question in a far better manner than I can. So more than happy to have a follow-up discussion there.
And does BrainBox AI connect only to airside HVAC systems, or can it connect to waterside plant systems as well?
So we download all the points from the HVAC system, so that would include also the water side. And that is an area we continue to improve upon. I think the person asking, or most people on the call, recognize that the water side is an important component of the energy consumption, so there's a large opportunity there. So yes, we connect both to the air side and the water side.
And do you need to add new sensors for getting data for temperature, like CO2?
No, our goal is to plug into the existing network of sensors that are in the building. So your HVAC system will have many temperature sensors, CO2 sensors, return air temperature sensors that are already available on a zone per zone basis. We often get asked the question, well, um, what if the existing setup is not as granular as you would want it to be? What we've noticed as we plug into more and more buildings, on newer buildings, more sophisticated HVAC installations, you'll have more granularity, and that will allow us to modulate the system in a more granular fashion. The flip side is the modern buildings are usually more efficient. In the older buildings, where you're not going to might have fewer sensors, less delineated, or fewer zones, it'll allow the AI to modulate less, but at the same time, the building is typically less efficient. So there's a higher bar at which to achieve energy savings. So there's usually that natural trade-off.
And have you entered regions other than North America?
Yeah, so we had our first installation. We went far and wide, and so our first installation outside of North America was in Australia. About a 1 million square foot shopping mall, and we have a couple more coming in Australia, and we've also installed in Ireland, soon in the UK, as well as soon in North Scandinavian country. So I think that speaks all to the scalability of the solution. For instance, in that Australian installation, we never sent a BrainBox person to the site. We were able to send our edge device. We connected with the local team in place, and we've been modulating the building since then. So that speaks to the simplicity of the install and the ability to manage at a distance.
And so Hassan asked a question in two parts. What type of partners are you looking for? And two, zone control is quite limited as at some facilities. What is your roadmap for buildings without zone level automation?
So on the partnership side, we are partnering up with certain, call it, if I can call it, distributor or people in local markets outside of North America. I'd be happy to have that discussion on a one-on-one basis, but clearly people involved. If there is a building that doesn't have zone level control, then frankly we'll tell the building owner that the AI can only do so much and work with what's there. If there's an investment by the owner to be made or being considered, I think one of the strengths of our solution is that for a lot of investments, we're able to shorten the payback, because when you combine that investment with our autonomous AI solution, you can generate some very meaningful savings, and that might take a payback that is longer. To continue to scale.
Sam, there's three more questions, but I'm going to combine two of the questions because they're tech-related questions, and then the third question is a real estate-related question. The two tech questions are, can you describe a little more how the AI works and what cloud service providers operate on?
AWS and Microsoft Azure. So we I think most people are comfortable with that. And then the other question to tell you, it would be a longer discussion to tell you more how the AI works, but basically, as I mentioned, what we seek to do is to give a predictive capability to the HVAC system in order to react before events are happening. I mean, at the core of the technology, that's what it is. Today's buildings operating when and engages, today's HVAC system engages when the temperature in the zone is either too hot or too cold. Schedules are set on a seasonal basis. So things are quite reactive and fixed. In our case, the AI is giving visibility 2, 3, 4, 5 hours out and allowing the system to react beforehand. Let's just quickly think about your start time in the morning. In most cases, you have a schedule by season. In the more sophisticated systems, you might have something that's looking at the average temperature of the last 4 or 5 days in order to potentially decide the start time of the current day. What our AI is doing is looking at the day ahead and basically calculating the smartest start time in the morning, including staging the various components of the equipment in order to do so in the most energy efficient way and reducing your peaks. So think about it, why does a building start up at the same time on the day where it's cloudy and rainy and 68 degrees versus the day that's going to be 95 and full sun, right? Those 2 days need a different startup, and our AI is able to calculate and deliver those individual startups each day. Same thing in an office setting when you have a shutdown time, to modulate that shutdown time based on the needs as we're getting to the end of the day, as an example.
Sam, I know we're over, but there's one last question. Is it required to be a whole building solution, or can this be deployed to a single tenant that may have a whole floor?
So I can answer it this way. We can plug into we can attach ourselves to the BMS of a whole building, and then only modulate specific floors or zones of a building. So we can limit the AI to specific zones or floors of a building. So we can do that, or we're plugging into the central HVAC system of the building. In terms of a tenant who has just one floor, it depends whether that tenant, in some cases, might have their own control in place, BMS in place, and might have some individual HVAC equipment just for their area, in which case what we plug into is what we can control. So if we're only plugging into the individual BMS, we can only control the components that BMS controls. If there's a central plant in the basement, obviously we won't be able to have impact on that central plant in the basement doing it that way. But if we plug into the centralized system of the whole building, we can certainly limit our involvement to specific floors of that building or specific tenants.
Sam, and if someone needs to get a hold of you or has any additional questions, how can they reach you?
So my email, I'll show it at the bottom of the screen here, is s.ramadori, so s.ramad as in David ORI at brainboxai.com. Personal mobile 514-236-1125.
Awesome. Thank you, Sam.
No, thank you, everyone.
And thank you to everyone that attended today's virtual demo day.